I'm going to go ahead and hit done. I think it'll be fine. Let me go ahead and log in here. This one. Sign in. So this is our last, we have 2 sessions remaining. We have today and then Wednesday's our last live session. So, let's see. Okay. Calculus for business. This one, well, that's why we take attendance. So, chapter 3. There are a total of 1 4 to 5. Okay. So give me. Okay, that's close. And change it from 3 to 5. Okay. Okay, we'll start off with question 69. We're here. Let me share my screen. Start the broadcast. Optimize. Okay, and we'll start off here. All right, gentlemen. So if you're just joining us, welcome. We are in the home stretch, the final stretch, right? So a little bit of a snapshot or play-by-play of the anticipated schedule, right? So Wednesday, which is next, in 2 days from now, is our last live session. So, today we're going to focus on chapter 3. Wednesday we'll focus on chapter 4. The reading period is this upcoming Thursday and Friday. And then your final exam should become available this Sunday morning at 11 a.m. And then it's due basically like 5 days later on Friday night at 11:59 p.m. I think that's Friday, May 9th. All right. And that Friday, May 9th at 11:59 p.m., that's your hard deadline for all assignments. Right. So everything is due. All right. So hopefully you've gotten caught up on your assignments as far as homework, quizzes, and exams. If you if you're going back to like do old assignments to boost your overall score, I would encourage you to prioritize your exams, right? Because those have a heavier weight, that's less work, and it has more, you get more bang for your buck, right? So if you're trying to maximize your overall grade, I would encourage everybody to prioritize the exams. And then once you've gotten your exams to wherever it is you want them to be, you want to prioritize the homework last, because the homework is a lot of work for minimal points. It's really practice to get you ready for the exams, and then we give you some compensation for it, but the homework is really practice. The exam should be the same as the homework, just with less aids. You have less support there. And again, idealistically, I want to encourage everybody to try to get caught up and finish everything now before you start your final. In an ideal world, when you finish your final, that should be it. All right, you should be done with the course. You don't want to finish the final and then you got like 12 other assignments that you're trying to make up, right? That's not a good look. Best thing is just go ahead and finish it now. You got plenty of time. This is the best time to do it. And then once you take your final, you can wash your hands of it and be good. Also, I would encourage everybody to check your grade on Blackboard. All right. So I realized that I think I automated the grading. So essentially what you see in Blackboard is what you can anticipate. I probably should go and update that and make sure it's clicking properly. I think there are some things I probably should update, but so just check your grade on Blackboard, check your assignments, and if you know you've completed something and it hasn't ported, just bring it to my attention so I can get to the bottom of it. We can try to make sure that that's proper. Just a reminder of like the extra credit opportunities. So when I go to calculate final grades, one of the first things I'll do is I'll take whatever your current midterm score is, and if it's higher than either exam 1 or 2, I'll replace the lower with the higher. Then what I'll do is I'll look at your final exam score and compare that to the midterm. And if your final exam score is higher than your midterm, I'll replace the lower with the higher. Then with that new midterm score, if that's now higher than either exam 1 or 2, I'll replace the lower with the higher. And then if your final exam score is still higher than your overall lowest exam score after all of that, I'll replace, sorry, Sorry. That's not you guys. Sorry. I went into that whole spiel. That's my next class. Sorry. They get that because they're like an 8-week course. The one for you all, for you all, the extra credit opportunity that I'm open to, but it depends if I can do it or not. What I like to do for calculus is your overall My Math Lab score, right? So if your overall My Math Lab score is basically what I'll do is like I'll take your overall My Math Lab score and I'll scale it to count for 10% of your overall grade, provided I can do it. Sometimes I went to do it in the past and they just skewed the grades entirely too much. Like it gave everybody like A pluses. I was like, okay, so obviously I can't do it. But that's actually a good place to be because that means that most of the students did really well, right? Like they didn't even need it. I think it was like tons of A's, maybe like a couple of B's, one C, and yada yada yada. I know we've had some students that have been MIA, but that's not your concern. That's why I keep attendance. And even if I don't directly purge them from in like Starfish or whatever, usually, especially somebody, the whole thing is like we keep the attendance, and then when I go to submit final grades, it's an F. It says, hey, when was the last time you saw so and so? And this was the last time I saw them, right? So that's where the records of attendance comes into play, which is taken automatically. Yeah, so that's a potential extra credit opportunity in the form of your overall My Math Lab score. I might scale it to 10% of your overall grade. It's just I'll do it if I can do it, as long as it doesn't skew the grades too much. I can't really do that other one. The other one is because that's a 8-week course. They're still doing a semester's worth of work in 8 weeks, right? So we kind of give them a little bit of cushion, but they go through the same anxiety that you all go through. It's a strong learning curve there, but that's a whole different experience. Let me see if there's anything else. So potential extra credit opportunity we talked about. One other thing is, if you haven't already done your course evaluations, be sure to go ahead and do your course evaluations. I'm not really sure how you access it. I know they've emailed the students. If it's still open, it may or may not still be open. So it should be. But if you haven't done it, just look for that. I know it's in your student email, and then there should be a link, and then that should redirect you. As usual, if you have questions, feel free to unmute yourself or type in the chat the Q&A. We can make sure to get it addressed before we go our separate ways. And let's go ahead and hop into some review. We'll start off here with question 69, right there. Now the next group, I do have to update their grades, though. I need to go through and pull some documents. So I'll probably just do it during class today, but that's under you guys' concern. So this question comes from section 3.3, question 21. It says determine the horizontal asymptote of the function. If none exists, then state that fact. Now, looking at this, it looks like we can use transformations from college algebra. Is this the right stuff? Let me see. Calculus of business. Like if you use, let me see. Okay, we don't need to do all that. We could do transformations, but I'm not going to do that. So in a calculus context, the horizontal asymptote, we're concerned with what happens as x goes off to either positive infinity or negative infinity, right? So if we focus on that denominator, as that denominator gets bigger and bigger and bigger, it goes off to infinity. That term within and of itself, that 6 over x, gets closer and closer to 0, right? So as x goes off to positive infinity, that gets closer and closer to 0. So then you're just left with 4. As x goes off to negative infinity, that term still gets closer and closer to 0. So as you go off to the far right or the far left, in either case, looks like we have a horizontal asymptote at y equals 4. All right, because that term tends to go to 0 as x goes to infinity. Type in equation, so what, y equals 4? Shut this down, off. Man, I've been like, I don't know what's going on. I don't know if it's me getting older or just things are changing, but I've been sleeping like crazy. And so I've been going on so many adventures in my dreams. And so a little trick that I've been doing as of late is like using ChatGPT to do a dream analysis. And it be coming back with some like interesting concepts. I was like, oh man. It was like, oh, well, that part of the dream is this and that, and I was like, oh man, that's interesting. So anyway, all right, so okay, we're good there. Let's do another one. Generate. Let's go to question 106. 106. Right here. All right, so let's see. It says a mailing service places a limit of 84 inches on the combined lengths of the girth of the distance around a package to be sent parcel post. What dimensions of a rectangular box with square cross section will contain the largest volume that can be mailed? There are two different girths. Okay. We want to maximize the volume. So the volume, what is length times width times height. So we see that the front and back faces are squares, right? So the volume here would be what, x times y, so x squared times y. We want to maximize the volume. And so then let me write it out. Let me, I think I want to have a seat. Ooh. Okay, that's right. Grab, that one's good. All right. Oof. I guess I can screenshot this. Let me get a copy and let's hop over to the notes section. It's a little bit small, but that's okay. All right. Right here. Okay. All right. So I feel like, this equation is fairly simple to construct because it's volume of a rectangular prism. So then the volume, we can write it as length times width times height. So that's going to be x squared times y. And our goal, we like to maximize the volume, right? So a limit of 84 inches on the combined length and girth, distance around, length and girth to be sent. So I guess as x plus y, it looks like so I think we got a second equation where we have, it looks like it's x plus y equals 84, right? Because that's not necessarily the volume. We want to maximize the volume. It says that a limit of 84 inches on the length plus the girth. So I'm thinking that's like x plus y, right? So then what we can do from here, we can solve for y, right? If we solve for y, we'll get 84 minus x, and then plug this into the other equation. So again, our goal is to maximize the volume. We got x squared times 84 minus x. Now we have one equation and one unknown. So then if we keep going, if we distribute, we get a negative x cubed plus 84x squared. And again, we want to maximize this guy. Okay. So then graphically, that's going to occur. We're basically trying to find the top of a mountain, the peak, the relative max, right? So that's going to occur where the derivative is 0, right? So let's go ahead and find the derivative of this guy. Let's go ahead and find b prime. So then it's going to give us a negative 3x squared. What is that? 168. Right. So then we want to find the critical number. So we're going to set this guy equal to 0. You solve. We can factor out, let's factor out, looks like a negative 3. Let me see, what is it? 6, 7, and 8, 14, 15. Yeah, we can factor out a negative 3x. All right. That's going to leave us with x minus, let me see, 5, 18 is a 6. 150 plus 18. Okay. So then we have it in fully factored form. We can use a 0 factor property. In other words, we set each factor to 0 and solve. So then x equals either 0 or x equals 56, right? 0 doesn't make sense in the context, in the problem. So it should be 56 should be our local max. Now we could verify, we can complete the first derivative test, or we could use the second derivative, right? That might even be easier here. Let's go ahead and take a look at the second derivative. I'll do it in orange. So if we look at V double prime, we could just use the first derivative test. If we were going to do the first derivative test, we would need a point on the left side of 56, a point on the right of 56, and evaluate them in the first derivative. And we on the left, we would anticipate what? We would need it to be positive. On the right, we would need it to be negative. Then that means we would have a local max. I want to use the second derivative test just for the sake of doing it. So our second derivative is going to give us what? A negative 6x plus 168. So then if we take this critical value and plug it in, let me see, 336. Ultimately, we're going to get a negative result, right? I'm not really concerned with the literal value. I just needed to know the sign. So when we plug 56 in, we get a negative result, right? Which means the original function is concave down, which implies we have a local, a relative max, right? When x is 56, right? So that implies that the volume is maximized when x is 56, and then I think we can find everything else from there. Let me see. That was 60. 24 plus 4 is 28. It looks like y needs to be 28. For the sake of time, I'm just going to go ahead and submit these results. All right. Instead of being super meticulous about checking. Right here, I got projects. I say like all this astrology stuff. I got so many things I'm working on. I'm trying to set it up where I'm going to take the summer off. I don't have a lot of resources, but I'm resourceful. Like a lot of times I don't be having nothing, but I still do everything. It's the weirdest experience. It's a little bit challenging, but it forces me to kind of use my analytical mind, and I always find a way. I always find a way. So it's really interesting. Okay, so the dimensions, we got what, 56? Let me check one more again. $56 and 28. All right, let's go. What happened? Let's try this again. Okay. 56. I'll come back to that. Let's go like this. 28. Okay. The dimensions are inches and inches. Okay. All right. So it's going to be shorter. Is that right? That seems weird. It'll be bigger in the face, the front and back faces, but kind of shorter. Anyway, let's just go with it. One or more. Let me see. All right, so we need to go back and check. All right, let's go back here. Now, if we say, let me see, if that's 5660, 24 plus 4 is a 28, all right? It's 56, correct. If we factor out a 3, that's a 5. 18, that's a 6, 56. What dimensions? Let me see. Amount of service limit 84 and a combined length and girth. Distance around a package to be sent. Rectangular box with square cross section that can be mailed. 84. Trying to see if I can find my error. Negative x cubed, 84x squared. Okay, 6. Oh, b prime, 3x squared. 84. We got that. That's a max. Negative 3. Yeah, we got that same number. Maybe I constructed it improperly. Length times width times height. Girth. Distance around. Oh, okay. Maybe we got the girth wrong. No, that can't be right. Girth. Maybe I did it horizontally. Maybe the girth is supposed to be vertically. And so like, but that doesn't make sense if x squared equals 84 or x plus x equals 84. So then I'm still not confident in that. I mean, that could be the case. Maybe that's where I got it wrong. The concept of girth, because I did it horizontally, like front and back. Maybe the girth is like vertically, right? So maybe it's the case that x plus x equals 84. So then what is that? 42. So x equals 42. That don't feel right. All right, I'm gonna look over here. Something seems funny. Review an example. Yada yada yada. Distance around to be okay. In terms of x and y, it can either be measured around the square with the side x or around the rectangle whose size. Each case needs to be considered. Oh, okay. Okay, I think we did one, but we didn't do the other. Now, wait a minute. They're getting 4x plus y. What? Start with the case of the girth measure around the square. 1, 2, 3, 4. Write an expression for the girth plus the length. So they did the distance around the square plus the y. Okay, so that's where we made our mistake. Okay, so we were missing the concept of the girth. It seems like there's another version. We're gonna make that all the change. I'm just trying to see if there's another version because it said there are two different that we got to consider. I'm just trying to get to the other one. Okay, that's fine. Keep going, yada yada yada. Second derivative, that's fine. That's exactly what we did. That's fine. I'm just trying to see. Okay, here it is. Now use the same method to find the maximum volume when the girth is measured around the rectangular cross section. So 3x rectangular cross section. What's that one? Okay. 2y. Wow. Okay, so that's strange. 3x plus 2y, and it's I'm imagining it's along the diagonal. Let me see. X squared plus y. Let me see. 2x squared. X squared plus x squared equals the diagonal squared. So 2x squared equals the diagonal squared. Where's that 3 coming from? Measured around the rectangular cross section. Oh, okay. So if we go 1, 2, 3, 4, that's a 2y, there's your 2x plus the x. Okay. Okay, so okay. I'm just trying to think of how to, I think I see it now, the two different methods. So look, what it seems like they're doing, right, for the girth, the way it looks like it goes, one technique is like if you have to say like this around, that's where like what the 4x, and you have to say plus y, right? So there are two, it looks like it's two formulas for the girth. The one I just drew in green would be something like L equals 4x plus y, right? And then for the I'll do brown, and I'm just gonna slide this over. Let's undo. Oh no! Come on! Oh come on! Throw me off right here. Okay, it's back. All right, so we got one of them. Undo. Okay. So again, I'm just using this as a reference. And then the other way that you can do it is this direction. So that was like vertical along with, you had to also add the missing side to calculate, to get the girth based on the context. So then this one is like this. All right. And then plus there's what, another X in the vertical sense. So it's like an additional one there. This other one had the additional Y that kind of went like this. Right. So if the brown is going to show up in the following way. Let me see. There's what, two X's and two Y's plus that additional X. So that one gives us, that's where the 3X plus 2Y. All right. So that's what we kind of didn't get proper, was the girth, the L part. But everything else we did was fine. All right. So we need to account for these two different versions or these two different scenarios. I think that's 4X plus Y here. And then, but everything else that we did was fine, right? Okay. So let's start off with the green. So again, the volume, again, our goal is to maximize the volume. And I think that was still x squared times y. But then the green, we had 4x plus y, right? And I think that has to equal 84. Okay. So then y equals 84 minus 4x. Okay. So then now we can express the volume as x squared times 84 minus 4x. Okay. 84x squared minus 4x cubed. Okay. We want to maximize the volume. Okay. So then that's going to occur where the derivative is 0. So let's look at v prime. I'm going to kind of rearrange it a little bit. 4 times 3 is what? 12x squared plus 168x, right? And let's go ahead and find our v double prime, our second derivative as well. Negative 24x plus 168, okay? So now the critical number is going to occur when the derivative is 0. So we're going to set that to 0 and solve. We can factor out, I know we can do at least 3. There's 12 going to that. If we do 3, I think it was 56. Can we do 6? Let me see. Maybe we can do, hey, Google, what's 168 divided by 6?
168 divided by 6 is 28.
28. Hey, Google, what's 168 divided by 12?
168 divided by 12 is 14.
14, okay. So it looks like we can factor out a negative 12x from both of these guys. We're going to be left with x minus 14 equals 0. So then from here, we get what x equals 0 or x equals 14, okay? So then in this context, this would be our critical number. Again, we would, if we plug this into the second derivative, hey, Google, what's 24 times 14?
24 times 14 is 336.
Right, so ultimately that's going to be a negative result, concave down. So that means this should be a relative max, right? So that's case one. That's for if we did it vertical, right? So now let's go back and do the same thing with the horizontal. I think we had 3x plus 2y. Let me copy this guy. I'm gonna paste it here. I'm gonna get rid of this. Delete. Okay. This one, I want these two. Copy, delete. Nope. Delete is hidden for whatever reason. Okay. And we'll work here. Paste. Okay. So now we need to do the same thing again in this scenario. Right? And then we'll have all the information that we need. I did not expect, so like, because of questions like this is why I do unlimited attempts and I try to give you the resources and, you know, minimal late penalty and stuff like that, because obviously this is kind of time consuming, but you know, it's manageable, you know. Anywho. Okay. Okay, so again, this is limited to 84 inches, right? So if we solve for y, divide by 2, what is that, a 42, 3 over 2x, right? Subtract, divide, okay. So then, if we plug this into the other, we're going to have what, x squared times 42 minus 3 halves x. Okay. Again, we're trying to maximize this. Let me see. Negative 3 halves x cubed plus 42x squared, okay? Factor out. Factor out a 4? Can we factor out a 4? What if we factor out a half? That's going to make that bigger, right? Okay, let me do this. I'm gonna start by, let me think. $84. 84 is a 12. Can I factor out a 6? It looks like we can factor out a 3/2 from both. Let me just do this and stop avoiding it. So then if we do this, there will be an X here. We do need to take the root. We'll do that in just a moment. The 2 is gone. Let me see. Minus. There's a 2. 24 is what, 8? Okay. Equal to 0. So if this is our V, let me go ahead and pull V. I feel like I'm losing myself. Let me see. I think I should have did V prime first. V prime 9/2 x squared 84. Okay. That's our volume. We got our V prime. And then I'll go ahead and do my V double prime as well. -9x plus 84. Okay. For whatever reason, I set the original to 0, but I think we need a V prime to 0. So we can kind of ignore that stuff over there. So let me see, if I say my V prime, it looks like it's this -9/2 x squared plus 84x. Let me kind of go back and check real quick. I think we're good. Let's keep going. Factor out. For factor out a half, let me start with just a half. Can I do 9/2? Yeah, let's see. Squared. Let me see, 168. So then for factor, let's just do 9/2. I'm pretty sure that's going to come out. Times x. It's going to be an x here, a minus. The half is gone. A 9 into that leaves you with what, a 7? No, sorry, not 7. There's a 1 with a remainder of 7. That can't be right. So maybe it doesn't go evenly. Okay. Instead of 9, let me try 3. And that would make a 3 here. All right. And then 3 out of that would be what? 5. 18 is a 6. Okay. Sort of a little bit weird, but maybe this is the case. So this is our derivative. We set it to 0, so we got to get it from that guy. I add and divide 1. Oops, not even. 26 is like what? 8 2/3. Hey Google, what's 56 divided by 3?
56 divided by 3 is approximately 18.67.
Okay. All right. Okay. So from this one, I feel like I'm pretty sure I made some mistakes in there. So we get these two results, right? We got the 18 and 2/3 and 14. So then if those are our candidates, like if those are both relative max, then what we can do is plug those into our volume function, and whichever gives us a larger volume is our winner, right? Okay, I probably should just use my calculator. This one took way longer than I wanted it to, but sometimes it happens. Let me grab my calculator. And like me trying to rush. Hopefully I really feel like I made a mistake on that sack though. We'll find out soon enough. Like, struggling today. Okay, let's go here to y equals, and we'll put negative x cubed plus. Is that the right one? That's not the right. Okay, right here. We'll do a negative 4x cubed plus 84x squared. Did I use the right one down here? That's why that's off. I think we used the wrong one there as well. No, we're good there. No, we're okay. We're okay. 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 Wait a minute. Okay, it looks like we got two different volume functions. So let me plug in this other one as well. Negative 3/2 x cubed plus 42x squared. Okay, so we got two. Okay. So then let's go back to the first one. The first one we got when x was 40. So let's evaluate that one. 14. When x is 14, we got the 54 for the max for the volume. And then for this guy, we got a result of 18 2/3. 30 plus 24 is 54. 56 over 3. Okay. Okay, so it looks like the first one gave us a larger volume that fit our conditions, right? So we got a result of 14. That's the one we're going to go with. If we don't get it right, then, just have to call it a day because I won't spend more time on this. Okay, so but we found our error. Okay, so when it was 14, come on, back up. Let's go. Come on. 14, 40, 56, 28. We got 14 and 28. Is that what we got before? Wait a minute. 14 and 28. Okay. Okay, that's fine. All right. Moment of truth. 14. If this don't work, then I don't know. What an adventure. Come on. That was an adventure. That took us a long time. But yeah, like that's how it goes. I mean, we figured out what we did wrong. We didn't get the concept of the girth correct, right? And so then they explained that it was basically two different that you had to test. One of one of them was where like if you kind of do vertical, like you measured it vertical. So if you took that distance around the vertical, it was x plus x plus x plus x give us 4x plus the y distance, right? But if you do it horizontal, it'll be x plus y plus the additional x, right? There's an additional x in there. So we got to the bottom of that. That generated two functions or two equations for L. So then we had to do the thing twice for each one and then see which one produced the maximum volume. And then that's the one that we went with. That was an adventure. Okay, well, we do have a solid 20 minutes, so we are going to take advantage of it. Let's keep going. We'll go to question 124. 124. That was fun. 124. All right. Right here. Okay, so the table shows the marginal cost, the marginal revenue, the marginal cost, and the marginal revenue. How come there's not an and there? I feel like there should be an and there. For producing X items. The third column, P prime, is partially completed. All values are in dollars per item. Complete the remaining entries in the third column. So the marginal profit. Revenue minus cost. Can we just subtract those? Yeah, it looks like so. Like I feel like there are two different routes we can go to fill in that last column. We can either find the profit function and then find P prime and then just fill it in that way. We also might be able to do R prime minus C prime. And I think that's the case. Let me see. So I'm going to just do the one that seems more simple for now. I'm just going to confirm that that subtraction works. 115 minus 154. Okay. And then 115 minus 595. Okay, so that's what I'm going to do here. So then it looks like that one is what, 0? Did you all get a chance to see Sinners? Oh man, Sinners. I enjoyed that movie. It was like the way he was able to just tell the story through music and invoke these different feelings. I was like, man, he did a good job with it. I enjoyed it. Okay. Okay, let me see. -7. What is that, like 90? 108 here. 108. 0 again. So then part B asks, what does the table tell you about the revenue function? Select one and complete the box if necessary. Looks so it's consistently producing the same amount of revenue, or the cost to produce one additional item. All right. Items sell for, there is not enough information to determine anything about the revenue function. Well, if R prime is constant, then that means that what? R is linear. Item sell. I'm gonna try the 115 that they each sell for 115. Let me think about that. Yeah, let's just try that. That kind of makes sense, right? 115. I find a production level that maximizes profit. Production level. So we want to maximize the profit. Okay. Well, that's going to occur where what? The derivative is 0. So our critical values are what? 10 and 130. The profit function. What section is this? 3, 3.6. Okay, so if the critical values occur when x is 10 and 130, and then on the left side of 10, we get a negative. On the right side of 10, we get a positive. So that's a local max. But then on the left side of 130, we get a, no, that's the local min, right? Because it's going from down to up. So that's a local min. But then for the, when x is 130, it's going from positive to negative. So that's a local max. So it should be maximized when 130 units are produced and sold, right? Because if you think about like the first derivative test, you know, to maximize, you set the derivative to 0, and we can see the zeros there already. And then, you know, the max is going to occur where, you know, left we have increasing, on the right we have decreasing, and that happens when x is 130. So let's go with 130 items are produced and sold. It's interesting. So a different way of applying the concepts that we've been talking about. Let's generate, try to get some more in here. 111. So I know we don't have a lot of time. 111. All right, right here. Okay, this comes to section 3.5 ACQ number 2, I guess. I'm not sure what subject that is. Accounting? I don't know what that is. A travel agency offers a package of $1,600 per person if they have 50 or less people sign up. For each purple in excess of 50 that signs up, the agency reduces the price by $20 per traveler. Complete the table to explore the relationship between price and revenue numerically. So number of travelers, if it's 50, let me see, 50 or less, price per person should be 1,600. So then it should be 1,600 times whatever n is. 1,600. Let's see, five times 16 is what? 50 plus 30 is 80. Is that 80,000? Wow. So then now for each additional person, it reduces the price by 20, right? So this one should be what, 1,580? I'll just go ahead and do the next one. And then what, 1,560? Wait a minute. Is there a limit? Like, what if you had like a whole bunch of people sign up? Oh, but that's for each additional person. It seems like it maximizes, like it limits how the max, because it seems like if you just let it run, once you get above a certain number, anybody above that, is it free for them? Or is there you're limited by the capacity? Anyway, I'm just thinking like if you push the limits, what happened? What is that? 1,540? Okay. Let's just do this. 51 times 1,580. 80, 580. 80, 580. Okay. So that 52, 1,560. 81, 120. Oh, shiesta. I didn't realize that was okay. Uh-oh. Uh-oh. Okay. Let me see. So one, that was 40, 2 times 20. So then 10 times 20 is 200. So that should be 1,400 here. 1,400. 6 times 14 is 60 plus 24 is 84. So 84,000. Okay. What's the time? The table shows the revenue. The table shows the revenue climbs if more than 50 travelers sign up for the package. Write the formula for the price if n people sign up for the trip if n is greater than or equal to 50. It climbs. Let's see. We want profit. Write a formula for the price if n is greater than or 50. So at 50, the price is 60 plus what? Or minus $20 for each additional. Let's see. So n should be each additional. Let me see. 16. I'm thinking it's 1,600. Let me think. Price 1,600 minus 20 n. 1,600 minus 20 n. All right. So wait a minute. For each additional above 50, right? So do we need to do like 50 minus n? I think we need to do 50 minus n. We'll probably have to simplify this. Okay, let's see if this makes sense before we submit it. greater than or equal to 50. So if we put in 50, the price is 16, right? If we put in 51, I guess we need to do n minus 50. Let's switch that around. Let's do n minus 50. Okay. So now if we put in 51, we're going to take off $20. If we put in 52, we're going to take off $40. If we put in 60, we're going to take off 200. All right. Okay. So the price. So now let me go ahead and simplify this guy. 1600 minus 20n plus, what is that, 1,000? 10 with 2 zeros. 1,000, right? Plus 1,000. 2,600 minus 20n. Okay, we're gonna check and make sure this works. Let me check before I delete my notes, right? When n is 50, 10, 1,000, 16. When n is 51, I don't feel like doing that. 102, so 10, 20. 10, 16, 15, 80. Okay. It seems like it's working. So let me kind of get rid of these notes. Hopefully this makes sense. We still got a good amount of time. We got at least 10 minutes. But I'm gonna go with this as my result. Okay. And then write the formula for the revenue for from n travelers when n is greater than or equal to 50. Revenue. Okay. So then it was basically that formula times n. Yeah, I think the revenue is just going to be that times n. So then, if that's the case, there we go. If we say that times n, we'll get what? 2,600 n minus 20n squared. Okay. Now we can check. Let's check a few of these, all right? And I think I'm gonna use my calculator. If I can. There it is. Okay. So what I'm gonna do is put it here. I want to check that revenue one. 2,600x minus 20x squared, okay? And I'd like to evaluate this when it's 50, we should get 80,000. When it's 51, we should get 8,580. Let's go ahead and let's just check the other two real quick. Okay, and then when it's 60. Okay. All right, so let's go with that. This. All right, we're going to submit it. Check. Ooh, okay, that was B. Let's keep going. Let me see. What number of travelers must sign up to produce a maximum revenue? Right. So we want to maximize that guy. That the max occurs when the derivative is 0. I'm gonna take some notes here real quick. So if we take our derivative, it's kind of acting up. Let's see. Let's do a negative 40 n plus 2,600. Right. So if that's our derivative, the critical number there, if we set that to 0 and solve, subtract and divide, 260 divided by 4, 2,600 divided by 40, 65. All right. Maximum revenue of this if 65 travelers each paying this. Okay. So we got a result of 65. We didn't check that it was officially like the relative max or anything. That was the only critical value we got. We got 65. I'm trying to type it in. Let's see. Can we just like So a maximum revenue of this is 65. Let's try this one more time. We get a result of 65 travelers. So the price they each are going to pay, so it's going to be somewhere between there. That's our revenue. Okay. 2,600 minus 20 times 65. Each pay 1,300. Revenue if each of them paid 1,300. And then we just need to do 65 times 1,300. So we'll say times 65. 84,500. And I think that is the largest number we've seen so far. Yeah, 84,500. So then what happens is are they like they're not maximizing their revenue if they go above 65? Let's see, that might be the case. 84,500. So now, like for instance, if we did 66, right? I think we got the revenue function in there already. I just want to evaluate this when n is 66. We should get something less than 84,500. Ooh, that's interesting. You would think that like the more people you would get more money, but it does kind of like feed back on itself, right? So notice that when we start going above, our max revenue comes down. Right, because that's what I was talking about earlier. Like, what's the limits? How far can you push this? Because, like, if you bring enough people, what's the bottom? Like, how do the numbers behave when you go beyond a certain limit? So, we can be confident in that 65. Oh no, sometimes it messes up. Let's go ahead and submit this. Wow, that was fun. I feel like there should be questions. Oh, we've got one more. This will be it. This will be it for the day. So it'll cost the travel agency for this trip if they have N travelers. Determine the number of travelers needed to produce the maximum profit. What is the max profit and what will each passenger pay? Okay, so this is our cost function and we got our revenue function, right? So there's our revenue function, there's our cost function. So then profit is going to be what? It's going to be revenue minus cost. And we want to maximize it. Okay. I probably should be taking some notes, like writing it out, but I'm going to try to do it here. I'm going to take notes here. It's acting up. I'm going to screenshot this. All right. We just need our revenue function, cost function. We want to maximize the profit. Okay. So I'm going to get a copy. Try to wrap it up. I'm watching the clock. I see the clock. My device is like struggling today. Not struggling, but struggling. I went and demoed the Apple Vision Pro this weekend. It's fun. It's something fun to do. Like, it's just something fun to do. It's free. You just go to the thing and they get your info and then they bring it out to you. Okay, come on, quick. Oh my goodness. Ooh, okay. If I don't drop the picture fast enough, I'll lose it. Then I gotta go search on my device. But anyway, we got it. Okay. So we're gonna try to wrap this up. So we got the simple thing. We're trying to maximize the profit. We have a revenue function. We have a cost function. So then profit is usually revenue minus the cost. So then that'll give us our profit function. Then we maximize it by taking the derivative, set it to 0, yada yada yada. All right. Okay. So let's try to knock this out. So then our profit, we're gonna do the revenue minus the cost. Okay. So the revenue, let's see, the 2,600 N minus 20 N squared minus the cost function, looks like it's 10,000 plus 200 N. Okay. So then if we simplify, we got this 26 N minus 20 N squared minus 10,000 minus 200 N. We do have some like terms. I'm going to rearrange this. negative 20n squared minus, let me see. So 24, so look, it's a 2400n, so plus minus 10,000. So that's our profit function. So our goal is to maximize the profit, right? So then what we're going to do is look at P prime. That's going to give us a negative 40n plus 2400. We want to set this guy to 0 and solve. Subtract and divide. What is it, 60? Profit is maximized when we get 60 people to sign up. Okay, for the sake of time, I'm just going to submit it because we're kind of out of time. Okay, so we got this result. Let me see. Maximize the revenue, but to maximize profit, we got what, 60? Now this is interesting that we're getting the max profit is not occurring at the same point for the max revenue. If we have 60 travelers, so the price $26 minus 20 times 60, 1,400. Did we do that one already? I think we did. 1,400. That's in the chart. $84,000? No, that's the revenue. So we still need profit. So then our profit we got what, 60? I'll just do this. So negative 20, 60 squared, 2,400 times 60 minus 10,000. 62,000 for the profit. That's the max profit, I guess. Yeah, when you factor in the cost, we got a 62,000. So even our max revenue was something else. We got 62. 1, 2, 3. $60. That can't be right. Wait a minute. Wait, I think I made a mistake somewhere. Because if we do 60 times 14, all right, let's just go with this. So I think that might be the revenue without factoring in. Oh, no. Let's just go with this result first. Okay. Oh. So, I feel like there should be questions, but you guys are adults, so I'll let you kind of do what you feel like you need to do based on the context of our structure. Let me see. So we did a review of chapter 3. It was a lot of like max optimization, maximizing, minimizing. And that was basically like first derivative test, second derivative test kind of thing. So then on Wednesday, we'll work on chapter 4 with integration. If there are any burning questions, we're going to go ahead and end this session here. And from one beautiful mind to another, take care. And we'll meet back on Wednesday for our last live session. Take care. Peace. don't see any notifications. All right.